Hello everyone, I welcome you all for the lecture series videos of mechatronics and automation. In the previous lecture series video, we have discussed about the uh, introduction about the control mode and necessity of control mode and their applications of the control mode in modern engineering field. And in the control mode, we have different types of mode. We have classified about the classification of control modes. Then we have discussed about the two-step mode and the proportional mode. So as a continuation of that, in this lecture series video, the remaining modes, control modes, we are going to discuss. So among them, we have a derivative mode. So the derivative mode is a special type of mode where uh, differentiation of the control parameters being take care with respect to the error signal. So let us have a deep dive into the lecture series video. So I am Dr. J.Yokesh, Assistant Professor of Mechanical Engineering, SNS College of Engineering. Is going to deliver a lecture about the derivative mode. So in the derivative mode, uh, the control function is with respect to the error signal. So the controller output is proportional with the rate of change of error signal. In the previous mode, proportional mode, we learned that the error signal is proportional. I mean, the controller output is proportional with the error signal. But here, the controller output is proportional with the rate of change of the error signal. So when you remove the proportionality, you have to introduce the constant of proportionality, that is KD. KD is the derivative constant. So in the formula, we can able to identify that uh, KD is the uh, derivative constant, and DE is the change of error signal, and DT is the uh, change of time. So DE by DT is change of error with respect to the change of time. So therefore, the controller output is the function of KDS into E. So the controller, as soon as the error signal is begins to change, it produces large output with respect to the error signal. So the initial response, it becomes large. When you see the graph, we can able to identify that the error signal is it is keep on increasing with respect to the time. That is constant change of error signal with respect to the time. So the controller, which produces immediate action as soon as the controller output receives the error signal. So the controller output is constant even though the error signal is increases. So it produces constant output even the magnitude of error increases with respect to the time. So that is the problem in the derivative mode. So because of this reason, the derivative mode is not alone used because as soon as the controller receives the error signal, it produces output. Even the error is very high, the controller output is constant, that is very minimal. Even the error increases with respect to the time. So this is the derivative mode circuit diagram. We have an voltage, voltage terminals, and it is sent it to the resistor, and we have a capacitor circuit, and the differentiator circuit is there, which differentiate the error signal with respect to the time, and followed by the inverter, and it produces the output signal. So because of this, the time being the parameter with respect to the error, so it has following disadvantages. So it never improves the steady state error. Steady state means increment of error with respect to the time. That is the problem. And it also produces some saturation effects and noises in the signal. So we have to suppress the noise and amplifies the signal in the system. So these are all the few drawbacks of the derivative mode. Because of these drawbacks, the derivative mode is not used alone. These are all the references for my presentation. Mechatronics, authored by Bolton, published by Pearson Education, second edition in the year 1999, and Bradley, Mechatronics by Bradley, uh, published by Chapman and Hall in the year of 1993. So in this lecture video, we have discussed about the derivative mode and its function, the output of the derivative mode with the help of graph. So I hope this video is useful to you. Thank you for watching. Thank you.